at the George Mason University, United States of America, and the Managing Director of the Center for Ocean Land Atmosphere Studies, COLA, in the USA. He was associated with IITM during 1965 to 1971. Professor Shukla has immensely contributed to the science of meteorology and study of climate dynamics that has led to the development of a scientific basis for the prediction of climate. His pioneering work helped lay foundation for dynamical seasonal prediction at the time when the community was quite skeptical about its prospects. He has authored over 250 scientific papers and has been an advisor of over 20 PhD students. Professor Shukla has also been an institution builder. He is well known for the establishment of the Institute of Global Environment and Society, IGES, and COLA in the US. He also helped to form a weather and climate research group at the International Center for Theoretical Physics, ICTP, Italy, which provides training to many scientists from developing countries. He helped establish the National Center for Medium Range Weather Forecasting, NCMRWF, in New Delhi, which was the result of a landmark agreement between then President Reagan from US and then Prime Minister Rajiv Gandhi. He has also established the Gandhi College in his native village for education of rural girls. Professor Shukla has won many prestigious awards such as Padma Shri, International Meteorological Organization Prize, Rossby Research Medal, Exceptional Scientific Achievement Medal from NASA, and many more. He is a fellow of the American Geophysical Union, Indian Meteorological Society, American Meteorological Society, to name just a few. Thank you, Professor Shukla, for accepting our invitation and becoming our guest of honor. I welcome you on behalf of IITM and request you to please deliver our Foundation Day lecture.
Yes. Okay, I can start. Honorable Secretary, MOS Secretary Dr. Ravichandran, Dr. Krishnamurthy, Dr. Krishnan, and friends in the hall. It is my absolute distinct honor and privilege to participate in this Diamond Jubilee anniversary celebration. And I really like to thank Dr. Krishnan and Dr. Ravichandran to giving me this opportunity. I had prepared two separate presentations according to the old schedule. One to when there will be opening session in the presence of Honorable Minister, and then our real lecture. So when it's combined now, I didn't have time to go back and change my talks. So I just replaced Honorable Minister to Honorable Ravichandran. Okay. And basically I have decided to just give the first 5 minutes while the lights are on, what I would have said, okay, in the morning, in a way, and then I'll give the second part. That's why I told the young lady to give me a notice. I don't want to delay this program. And you see, IITM is where my life in meteorology started, okay? Somebody was just, people have come at different times here. Well, guess what? I worked here 58 years ago. I was 20 years old, and God's grace, whatever it is called, I got a junior scientific officer's job here, okay? And in fact, I was looking for how many people I know who might be here And then I finally found last night, V. Brahmanand Rao. He actually joined soon after me, just a few months later on this. And I mean, there is, so Keshavarthi reminded me of Pisaroti. There's so many stories I could tell you, but that will take all the time. I also plan to say stories. I've got, there are two parts. But then I got these 3 envelopes just now. And I'm just so delighted that these 3 people, I had such a huge respect for them. Dr. Pisaroti, Dr. Radhakrishna. And Pisaroti, you can just talk to him and you know, I mean, he will talk like a friend, he was a real scientist. And Radhakrishna, every time we'll go for the map discussion in the IMD, we really engage him. He was sort of the discussant. And Anna Mani, you will not probably believe how I knew her so well. Because the IMD guest house was in Ramdur House. Those of you who might remember. Where? Next to my office. And many days I'll be working late in the evening, and then I'll see this young, lady in a sari coming out right there, and she will ask, "Oh, you're working late?" And then I started talking to her. So every time she will say, we really got to know her very well. Thank you very much for this. This is a great honor that you have honored them 3. They're just really amazing people. So, as I said, you know, if you look back at the establishment of IITM, it's really the dawn of a new era in weather and climate science for the country, not just for IITM. And in some way, I feel very privileged to be involved with it for the 58 of those years, because this institute has not only excelled in research on modeling, prediction, predictability, climate diagnostics, observations, field experiments, taking observations through field experiments, and most of all, training a new generation of weather and climate scientists. And actually, it has contributed to the overall development of weather and climate enterprise. And it is quite remarkable that now, Dr. Keshavarthi mentioned, some of the most advanced models are being used in India. And IITM has played a role in providing these models to the operational IMD. And these predictions are saving lives, saving property. This is a, I mean, you know, our field has one problem. We cannot sort of take credit for what did not happen. Okay? It's very hard to take credit for. The only way you will have to just show, look at the same cyclone killed 11,000 people before, and now 4 people. So, you know, if you can explain that, then the people will understand. So anyway, I will just make a few science comments now before going to my talk. That as a secretary and even as a minister, there will be a requirement of public's expectation of better and better forecast, higher and higher. Give me village level forecast, give me district level forecast, and so on. Look, I have been working on the field of predictability for most of my life. Ed Lorraine, who is the father of chaos and predictability, was one of my 2 advisors, well, one of the 4, Johnny was the other one. So I can say with some understanding of the problem. I think we have to be just very honest to tell the public and tell people that, look, there are limits to predictability. And these limits are not imposed by how hard we are working and what we are doing. They are imposed by laws of physics. And therefore but doesn't mean we have reached those limits. That is our goal. We want to strive to reach those limits. Then if you come to IITM, if there is any organization in the country, and now it is comparable to the world, which can actually give a scientifically valid, real justification to show what are those limits, there's IITM. And it is working on it. I'm so happy to see it is working on medium range, weekly forecast, seasonal, and climate change. And I'll talk a little bit more about that in the future. So I think that, the only thing I'll say about the future of climate modeling is that, and I mentioned to Dr. Krishna yesterday when we were talking, every modeling group in the world is, of course, struggling to get bigger computer, more funding, and improve, models are improving. However, we have also realized that just like the physicists, each physics center in the world had an accelerator. but none of them were so powerful that they could do what CERN does in Geneva. Okay, you needed 7 teravolts. But same thing in climate is going to happen. I think all the countries in the world are expected to collaborate while building their own modeling center to create some level of international sort of institution which will really do things which are impossible to do now by anybody. Now you may ask, what is impossible to do now? I'll tell you. 1 kilometer global model is impossible to do now by any institution. And if you are interested in regional climate change, if you are interested in, you can do a 1 kilometer global model of 5 days, 10, maybe. But right now we are doing like 3 kilometers, the best anybody has done. So you see there are problems, and they're not just computer problems. They're scientific problems. We need to understand that. So just keep that in mind, because very soon, Dr. Chandra, Dr. Krishnan, I can give you advance information. You will be getting an invitation to come to a meeting in Berlin, where the world community is getting together. They call it the World Modeling Summit #2. Some of you must have heard about World Modeling Summit #1, which 2008, I think Tim Palmer and I had organized, and it really helped. So that's about to happen in June. So all right, so I really think that I would like to end the introductory part of the lecture, by simply congratulating both Secretary of State of MOES, Director of IITM, for nurturing and supporting this institute, which I consider to be a shining jewel in the crown of MOES. I think that more than anything else, I would like to congratulate the, of course, IITM Director, but more than that, IITM staff, very hardworking. See the number of publications, see the amount of, and for making it possible for IITM to be the world-class research institute. So, thank you again for inviting me. Congratulations, and I will end my talk with applauding for you. All right. So let's just go to the second part, and before you start showing the slides, I just want you to know what I'm going to do. It's not a conventional talk. I asked many people, what should I talk about? Everybody said, Jo bhi aapko aaye dimag mein. Whatever you want to do, just do it. And I said, okay, so I chose the following strategy. I'll just tell stories about when I came to IITM. But I'm going one step further, and I hope you'll bear with me, to tell you what I was before I came. Somebody was interviewing me about some stories, and the reaction, this person says, oh, the chaos in your personal life is much more than chaos in the climate system. And I could realize, and I'm not going to go into the details, but the only IITM example I can give you is that I came to join, and they asked me to sign a form. There was a form, married or not married? I said, married. Wife's name? I said, I don't know. No, I'm not joking. That's when I was 17 years old, and my marriage was fixed. I got married, and I never saw her. Only when IITM sent me for the training abroad, it was arranged. So my point is that the background through which I came here is something that is quite unusual. I would like to share with you, and then I'll go to IITM, what happened. Then from IITM to MIT, I get confused with IITM, and by the way, first we used to call ITM, do you know that, in the beginning? Then it became IITM. So that's what I'll do, but then in between, I'm going to talk about scientific ideas and how the research ideas develop, and that will be the message for the younger people. And the message will be very simple. You know, if you have an idea, just don't hesitate, just come out and say it. And if you're not a good idea, and I'll give you examples, what happened to me in, just imagine, I was interested in long-range forecasting, and I'm going to MIT. As a father of chaos theory, he's one of my advisors, Sean. So I'll tell you those stories. And then I'll mention a few things about other experiences with IMD. And then I'll come back to the science part. Okay. So that's why I say I've told her to give me notice that what it is. Okay. So I should say it's not that 58 years ago I worked for 5 and left. No, I have been very much involved. I really and I very much enjoyed this interaction, okay, over the years, sometimes more, sometimes less, including scientific discussion. Just only a few years ago, a group of scientists from my group came and published. They said they have a problem with this paper by Goswami and Sahai. Goswami is my great friend, but we have different opinions in science sometimes, which is very healthy. So we wrote papers, we did, so both are published. Here's the paper, here's the opinion. So I'm saying it's a genuine scientific collaboration. I think many years ago, Dr. Krishnan came to visit. When I was at NASA, Dr. Goswami came. That's where we wrote the paper about predictability of the couple model, because I was doing only predictability of this. So anyway, this is really a great opportunity. So I just want to young people that I'm not showing my own experience with the research. So I was afraid when I prepared the slides. It may look like I'm sort of trying to brag about what happened. Please don't think of bragging. Think of it that, somebody, Krishnamurti says, coming home and just telling your home, hey, look, I've done certain things. But then I'm not just saying that to do certain things, but there is a message about how scientific ideas develop. So I've chosen 3 scientific ideas, and I'll talk about that just briefly, each one of them. So I really think that the part that I find interesting is how when I came to IITM, and before I start showing slides, I can just tell you 2 stories that again many of you may not know. I didn't study meteorology. Okay, I didn't study meteorology. I studied exploration geophysics in BHU. Meteorology, you take 1 paper, and I was working in oil and natural gas commission at an oil rig. But somehow from BHU, I had applied for some job without knowing what it is. We never heard of IITM. They got an interview letter to come to UPSC. And my roommate in Dehradun also got it. He was a physics student. And I was about to throw that letter. I said, this is from meteorology. We are here. He said, no, don't throw. I have also got it. No, you should come. I said, but they will ask me questions and I don't know. I said, no, but you'll see Delhi. It's good for sightseeing. I said, why do I want to spend all the money sightseeing? No. He said, you will get a 2nd-class train fare, UPSC gives. But everybody goes by 3rd class. And by difference, you can have per diem. You can eat food. Then I said, where will I stay? I said, you will stay at my house. He was from Ghaziabad. So this is an honest story. I said, okay, I'll come. I stayed with him. I went for the interview. Do you remember when you know you are not going to get this job? When you know absolutely no chance, you are here only for per diem, not for a real job. You are so relaxed about it. And I think this, I don't know, God bless the UPSC panel. They will ask me questions and my reaction will be, really? That's so? And then one of them asked me that hail, when you cut it into the middle, there are concentric circles. I still remember that question. I've never heard that before. So this is what I heard. I said, oh, I didn't know that, but let's think about it. And honestly, I was sitting there, I said, let's think about it. Maybe at the sort of small hills, rising up, vertically, going up, because that's what maybe it's depositing more water. It's just, and they were looking at each other, oh, so I probably fooled them because they thought this guy can think about. So anyway, guess what? Next thing I know is I got the job offer. Okay, and I came, and for the first 6 months, I didn't know what am I doing here. And my roommate here in Pune was preparing for IAS, and he said that IAS ke liye prepare karo, you should go for the IAS. And guess what? I started preparing for IAS because I don't know meteorology. Pisaroti is such a great man. He walks around the offices, and he said, "How are you doing?" What are you saying? And again, see, this has been my habit from, and I'll tell you more stories about it. I just tell the truth. And sometimes it sort of works, sometimes it doesn't. I said, sir, sorry, but I'm preparing for IES because I don't know which one. He just looked at me, didn't say a word, went back. When I told my friends that happened, they said, I can't believe you have done this. I can't believe this. I said, guess what he did? He goes back and recommends me for the UN fellowship to go to USA and Japan. Okay? And the letter that came from, not letter, those used to be TP, came from DGM. Shukla has been selected. Look at the coincidence. It was the same day my roommate got rejected in his IS exam. Okay? And I just talked to my family, my friends. America जाने का chance है? Absolutely. There's no point. You should go. I tell you, then I started studying meteorology. So it was just in 6 months. K.R. Saha was the assistant director of. He said, you have to learn. And he gave me a review paper on tropical cyclones. I had to present it. So that's what I said. I used to read day and night, I used to work. That's how I made honor money in the guest house. I learned programming because of IBM 1620. Although some of us were learning programming because the room was air conditioned. Okay? And that was attracting, a lot of interest. But anyway, that's really what happened. I got, and we managed to develop a small barotropic model. But we used to run, what should I say, take a train to TIFR, okay, to run the models and to come back. And one day, it just occurred to me, just going back and forth because I had why can't we ask somebody at IITM, staff, there are a lot of assistants, that they will go every day because you have to wait overnight to get the output. So all of us will keep our punch cards ready. So I asked Saha to make a leather bag, just fitting the card. So all of us will give him the card. He will take the morning train and bring back the evening train, the outputs from the day for yesterday. So I take some credit for creating the first remote computing, okay, in the much faster than whatever it was. Anyway, I really would like to then give you, I was supposed to turn my, how much time I have already taken? Because this was not part of my talk. I have 25 minutes left. Okay. All right, good for morning. So now we're going to a very fast speed of, so I just said, okay, can you put the first slide, please? And then after that, I'll keep clicking. Should I just click on that? Can you see the first slide? How do I do? Just go to the first slide. Yeah, and then I keep, okay, just click it here. Okay, all right. So that's fine. I just say, this is a fast slideshow before I came to IITM, all right? So this is my village. Oh, by the way, so this was my outline, I told you. So we'll come to that, okay? So this was supposed to be the last slide. Where we are now, by mistake, it was, my assistant put it on the first slide. So you'll know, okay? But this is my little village, okay? Just you can get an idea of where I came from. There was, for agriculture we were doing, to oxen we had. This was my light source up to middle school. Okay? There was no electricity, there was nothing, just kerosene lamps. And no paper. Yeah, this is made of wooden thing, okay? This was the transportation. So from village to go to Balia city, that's something that you could go, okay, sometime, okay? But once in a while, I got to go a long distance by an elephant. Suppose there is a wedding. And when I told this story to my MIT friends once, that my high school teacher came once, I said, but there's big water nala, and my bicycle will not go through. He said, don't worry, I'll send you an elephant. And he did. Okay, so, and my MIT classmates will not believe. This was now this primary school is recent picture. Before there were no this thing, it was just wooden, not wooden, clay. There were clay walls, but it is this. And the cheating is so prominent. This is from New York Times in the college in Balia, okay? So I just somebody wanted to say, do something. So my mother and my brother said, you're going here and there, what have you done for the village? So I said, fine. So we started a college. And that has been a very, very successful experiment. There are about 1,000 students, 80% are girls. We named it Gandhi College because these guys will come. आपके पास नल का क्या system है? नल करने, नकल करने का. How would you do the cheating? I said, no, we are not going to do cheating. They will laugh. They will think. Anyway, now they have all accepted it. So we give free bicycles to the students, those who can come from the neighboring villages. And of course, this is one of the inauguration days. So that is my village, okay, before I came. This is the IITM I came to, okay. So this is Ramdur House. That's where we have, and you see, that's, the reason I was delighted to have this occasion is that you just can't imagine what IITM has done for me. First of all, again, thanks to Pisaroti, see, they sent me to the US for this training. That was an amazing experience. See, 67, 64, yeah, I was less than 23 years old, okay? And you can recognize Sikka, Krishnan, all four of us went together, okay? And it's an amazing experience. We used to live in an apartment, security was so lax, we'll walk into the White House lawn and have a lunch, a sandwich sometime. Then, being at BHU, I found that there is a way to do PhD. It was not there, but we established it. So that's how I managed to get my first PhD from here, whatever work I have done. Dr. K.R. Saha, P.K. Das. So this was my thesis committee. Then IITM sent me to Japan. And I met really two distinguished scientists, Matsuno and Gambo. By the way, in a hurry, I put some of the pictures I don't have. You can see that Matsuno was very young. Well, we were all very young. Then later on, I realized how famous, he became for this. But look at the luck. So coming from the village, I go there. I resigned my job here because I really didn't think I knew much, okay, about meteorology. And I had met Charney in another meeting, Tokyo. And I don't want to go into that long story, but in very brief, that IMD had sent me to this NWP symposium in Delhi. And I was totally surprised because there were two people who really wanted to go, Dr. Asnani and Dr. P.K. Das. But these were the kind of leaders. Somehow Dr. Ellis Mathur, who was the DGM, decided that, okay, I'll go. As I say, don't ask me what, I don't know anybody, nothing. It's just, of course, one difference was that my paper was accepted for publication. Then, and the DGM was not keen on sending those two people. That's what I was told. Anyway, and then I met Charney because I was trying to present some paper which sort of criticized his work. And I didn't know who Charney is. So I asked somebody, Kaun hai, who's Charney? So they showed me. And then I found out he's the most famous man of this, meteorology. And then I finished my presentation and I was so relieved. Then he says, I have 4 questions. And then I sort of went back and forth, and all the room was turned. There were like thousands of people. This was an international conference. And I thought, oof, it's over now. Then he came to my table during the coffee break. So I want to give you another paper I have written. That is the moment that changed my life. I said, you know what, when I go back to IITM, I'll try to apply to study at MIT. That's really what, long story I start, and I applied. But then, then once I was at MIT, actually at MIT, there are a lot of opportunities, and some opportunities come, and some opportunities, basically you have to take. T.N. Cole came, he was the ambassador, India's ambassador, and he said, oh, anybody has any ideas about what to do? I was a graduate student, and I raised my hand, I said, yeah, I have one idea. I said, IMD needs to be improved. Oh, what do you mean? So this has been my habit from the beginning. I speak out, I just say if something has been done. Some people get mad, sometimes it works. Sometimes, there are many examples I can tell you where I have to pay price for it, and then there are many examples where it's successful. But in the end, I feel you are more relaxed if you just stick with the truth and whatever you think, then you can justify it. So I told T.N. Cole that this IMD, I said, why? Why do you think it is? And I had heard in Pune that DGMs are selected by seniority cum fitness. I never heard this word before, seniority cum fitness. I said, that's just the opposite of any excellence. How do you bring excellence at the top? If the only way you can get to the top is by seniority cum fitness, you can be mediocre whole life and then you can become head just because you're senior. And I remember I was so young, I had joined here, and people will tell me, "Tum IMD mein jao, if you go, you will become DGM in so many years." I say, okay. This is part of the calculation. So he wrote to the Prime Minister about this, and then the Prime Minister set up a committee called Ramanna Committee to examine this aspect. And I was glad to see it was actually changed. And that system was changed, that there will be a direct recruitment for the DGM. So many times you take small actions, and it does have, my own plan was to really return back to India, by the way, and I will not go into the detail. I was offered, just after his PhD, to be the assistant director of FRD, same Forecasting Research Division. But India's emergency and what happened to my family, there were many personal reasons I didn't come. But I continued to work with IITM all this time. Just regularly, people will have, I'll do that. So I don't think that I have time to really go, but it has been really, my work with NCEP helped me sort of bring the weather forecasting model to NCMRWF. Again, by pure coincidence, suddenly I got contacted by Guwarkar that they're trying to buy the supercomputer, and I got so excited that, see, nobody will pay for me to travel. Nobody will pay tuition for my children if I stay in Delhi. But I was so excited about the project that my wife went to her parents and we rented the house, and so that was producing enough income. And WMOs, WCRP, they decided to give my airfare. So I came 14 times in 18 months. And every time I'll bring a tape, I'll bring a software, I'll bring some equipment, but Guwarkar had told the Prime Minister it will take 3 years. I think within 18 months we made this operational. And it was one of those big, you feel good about, you see something, suddenly change really the nature. It was the first time a global simplification model. Then, of course, we continued that collaboration with IITM, came several times here. I think Hemant Chaudhary from here came to Kola, and then I worked with NCEP. Let's see, I don't know, you can hear me, right? Yeah. I am assuming this is only to protect me, not. So anyway, and we got started with Dr. Krishnan came to Kola many years ago, I remember, on this. So it really has been but again, I got a phone call from the embassy that Dr. Manmohan Singh wants to meet with you. So I met with him, and I told him what is on my mind about the weather and climate change. It was 2006. And when he came back, he really created a new ministry, Ministry of Earth Science. And he and Kapil Sibal made me the chairman of this IAP panel. So I was very involved year after year. We'll have many times in this. But then I was surprised that Prime Minister Modi then appointed me to the climate committee. There's a Prime Minister Council on Climate. I don't think I remember any mayor, but I don't get any invitations to attend the meeting. Last time I attended the meeting was at Paris Climate Conference, which was great because I was the Indian delegate. So in the Paris Climate, because as a member of the Prime Minister's Committee, so you can go really inside. So anyway, just to end this part, because I really need to talk about the science, my affection for India, for Indian institutions, there are many other institutions I work, my village, my family, so that, I have come at least 100 times back to India during this time, because I make that, the only I haven't come is last 3 years or so. So all right, I think that, let's just go on to, so that was nice to meet Charni, Lorraine, he was my advisor. I'll just fast forward. Again, chance meeting with Salam. So I managed to create this group, and we have. And IITM had many, many years of joint program, and I hope that someday IITM will start again. Okay. So there are many, many meetings, and so he's my fourth advisor. So Charni and Phillips were advisors. Phillips quit. You guys might know, went to NSAP. Then Charni, MIT had 2 advisors. Then Charni went away, and then they made me go to Princeton. And then Manabe became my advisor. And guess what? Manabe is the first one for our field, which is a great thing, by the way, for our field. So, all right, I think that you are sure I have only 15 minutes left. Is that correct? Okay, all right. So let me just tell you about 3 ideas. And the reason I'm telling you about these 3 ideas because I know how do the ideas come and how do reanalysis is one idea, and you don't have to go into this. Toga panel was looking for some way to organize data and produce. And I happened to in NASA, assimilation is not my expertise, but I saw Halem and Colney were doing it. So they were looking for ideas. So I just wrote a 5-page idea that why don't you do reanalysis? And guess what? It just slowly it caught on, and then now it has become a major source for data. The idea of the seasonal prediction is really what I feel very interesting. And there again, I have to tell you, something to do with the background with the village. I had experienced the monsoon droughts. I was not in meteorology. Monsoon droughts cover the whole country, very large areas. They persist for the whole season. So I couldn't believe that such a system will not be predictable. So I just want to be very clear. It was not my insight or some deep knowledge. It was intuition and my general belief that nature cannot be so cruel. So there must be predictability. And we have to figure out how to exploit that predictability. But I couldn't work on it as a thesis topic because you can't do our thesis at MIT. So I did my usual 2-level linear instability problem for the instability of monsoon depressions. So I think that to give you the simple idea, I had done GFDL model Arabians experiment, and then I had saw at Princeton, I was just walking around in the corridor, and this guy showed me the snow data. And when he showed me, I saw it's just upside down Indian rainfall. And so we wrote a paper, and it became kind of important for cryosphere people because they didn't have it. So when Chani told me I'm going to India and I have to talk about monsoon, but I don't know much I mean, he knows much, I haven't done anything. So I told him that, you know what, India is interested in protection, and here are some ideas. And he got very excited because he himself had done an experiment with albedo. And he found that if you make random perturbations, changes are not large. And just in that one conversation, that became an idea for his presentation. And that's it was done. And those days, nobody believed this possible. Just remember, okay? I was involved with this meeting in '82, and WMO will not agree to make the title climate prediction. They said, no, there's no basis, there's nothing. But then finally, we negotiated, and they agreed to do it, physical basis for climate prediction. So anyway, now, I think many of you know the basic science behind it, and I will just go so fast. So if you know already, it doesn't matter. If you don't know already, it doesn't matter either. So that's, I'll just tell you is that the main point is that there is a lot of persistence. Long waves have a lot of memory. So you can have some sort of, predictability means memory. Okay, so even without ocean, you have memory in the long waves. That's why you can predict. With ocean, you have the memory in the upper layer of the ocean. With land, you have memory in the soil wetness. So these are the 3 sources of memory. And that's why we get the predictability, but we have to show. So the reason, the way I showed was, I have named it billion butterfly experiment. Because people, so it's the same paper, but I'm telling you what I mean by billion butterfly experiment. In a butterfly experiment, you make a random perturbation and see where the model goes. I said, no, I'll make as large a perturbation that a billion butterflies cannot do. See what happens. So I took the initial condition in '83 and initial condition in '88. And you all know these were the 2 extreme initial conditions, okay, of the atmosphere. And look at the southern oscillation. Look at how extreme they are. Take that initial condition and run the model. Guess what? The solutions converge in about 10 days. So what happened to the butterfly fan? So I always use that in my class. It's magic. Think of a gas. But this is the wind in the tropics. What about the rainfall? Look at the rainfall. Seasonal mean rainfall. It's a full GCM, okay? You are starting with 2 initial conditions which are completely different. And they're converging. That gives, why they converge? Oh, and not only tropical rainfall, but look at the extratropical circulation. Converge. Okay? So I get this excitement among the students. Try to guess why, what happened. Guess what? This is what happened. The only thing I was using same in the two models was the SST. So the tropical SST was the observed SST for one of those years, that year of 83. And then it just met with it. So just that's the basic idea of that, why there are exceptions to the butterfly effect. That the boundary effect is so large that you can actually overwhelm. So I'll just fast forward. Then you ask, how about the ocean? That's the tropical atmosphere. How about same story? Take the tropical ocean for the same 2 years and force with the same atmosphere. But the initial condition of the ocean is completely different. Guess what happened? It converges in 4 months. So what converges in the atmosphere in 7 to 10 days, which is really the tropical atmosphere directly responding to convection, is in ocean. So that shows right away there is a memory of the upper ocean, and you can predict at least up to 4 to 6 months. So these are the ideas that really came to, and I don't want to go into more details. Land was really another one that is very important. Nobody believed land is important, by the way, in 1980s. Okay? So again, this was an idea that I got by reading one of the Chinese papers and Bill. So Yale Menz and I said, let's do a crazy experiment. Let's make the whole world parking lot. Whole world. And then let's make the whole world vegetation. Just, we can do that in a model. Run. Look at the difference. Guess what? These two full GCMs, the difference, just by changing the ocean is same. Just by changing, difference in the temperature, 20 degrees, 30 degrees. So it showed, for those who are not convinced, that how important land is. And this is something that it took some time for people to recognize, that, the evaporation from the land alone can explain 60% of the rainfall over land. So evaporation from the land is a very big factor. It's not that all the water comes from but which molecule rains and which molecule evaporates, that's something that you have to study. But the number-wise, the budgets, 60% of the land rainfall you can explain by the 60% evaporation. All right, I think let's just go on. So, by the way, so polar people have done and shown that land initial conditions can contribute a little more, not as much as tropics, but I don't have time to show you. The main result they found is that initialization of soil wetness, that's something we can pick up for the afternoon session, is very important, because without that, and the only way you can do that if you have very high density rainfall stations. Okay. 5 minutes, okay, I'm getting the signals, all right. So, well, I wanted to talk to you about the current skill, where are we, okay, and I had a 65-year results. And situation is not very good, as Keswamurthy said. You see, the current skill of SST is very high, see correlation 0.7. Current scale of rainfall, 0.29, is very small of the monsoon rainfall. So even if you can predict the SST, so that's a challenge that we should discuss in the afternoon session. Sometimes these predictions are very good. By the way, this is the prediction of 72 by the same model. So I've done it for 65 years. Look how good it is. But this is, of course, done today, not in 72. But if you look at the 797, it's wrong. So that's another challenge for the afternoon. Why the boundary effects sometimes work, sometimes they don't work. So but in general, seasonal prediction skill is going down in the Eastern Tropical Pacific. And there are many good scientific reasons. Is it to do with the systematic error in the global warming? We can do that in the afternoon. Okay. But look at the story of weather prediction. It's going up, not for the seasonal prediction. So we'll come to that. Okay. So I think that that's why we have to focus on improving the models. By the way, some people, when I say that, some people say, oh, you always will find excuse why the predictions are not so good. No, we have to. The problem is that our models have such large systematic errors. The fact that it doesn't interact with the signal, well, that's our good luck. That's all I can say. That still we are able to make predictions, but we should improve that. But then you all know about the World Modeling Summit. We are actually really trying to get countries in the world to unite, and we are hoping that eventually the world will have a climate summit. That's the idea that we have. And now, this is unfortunate, but the next set of slides were entirely about new results. So if someday in future you can tell, but our new result in one word is that Indian Ocean SST is very important. The heat sources, along with Indian, and that actually could explain a lot of things, not just the Pacific. That's just the one word message, okay? The second research was intraseasonal fluctuations. What do they do? And these are the ones that were converted. And we have this notion that, intraseasonal variation, break monsoons, are very different during the drought years and floods years. It's really not the case. If you look at the numbers, they look like, but if you remove the seasonal mean, they become identical. So this is the doing a bootstrap. So we really need to understand what it is, what is the contribution of intraseasonals. And again, Krishnamurti has done a lot of work, which I'm not going to go into this, but by looking at predictability of the intraseasonal variations and the seasonal mean, that's the framework that I was going to discuss into we can talk about in this thing. So I really think that, look at the intraseasonal IOD and ENSO, they totally explain most of the signal, okay? But we have a problem in predicting both the ENSO response as well as the intraseasonal response. So that's our challenge, how to do that. So I think that I've given you the summary. That's a challenge for afternoon. We really have to do that. Let's do. I think that I really will like to again conclude by congratulating IITM for doing such a wonderful job. And I was trying to keep, because it's a science talk, so I tried to keep 1 minute for questions. So thank you very much. And I've saved 1 minute if you have any questions. Thank you.
I request Professor Shukla to give your views.
Okay, first of all, I would like to say hello to my friends and we're remotely connected. I miss Dr. Goswami. I was hoping he's here. I don't know. He's there? He's there. Dr. Goswami, thank you for all you have done for enhancing meteorology, okay? And particularly IITM and particularly Monsoon Mission. I know the kind of ideas that science. So I told in my lecture, you and I don't agree on everything, but we have to respect the science contributions. When it comes to the proposal, since I have only 3 minutes, I'll be very fast. I completely and wholeheartedly like your proposal. I tell you why, Dr. Krishnan. Most of the experiments are always observational program. I have been involved with many of them in the last 40 years. And are modeling experiments because I'm always involved in the modeling, but the observational panels also invite me as a token, Brahmin, in their observational modeler. So I get to see both. This is a great idea. It should be a coordinated observations and modeling both. And so I think you should go full ahead. But I have three kind of, not criticism, but 3 comments on this. You cannot be sort of ambivalent about 3 to 4 years. I think you should say it's a 5-year program, okay? It should do. Second thing is that you should launch it. Don't worry about how many other countries are part of it, but then try to include and try to suggest that to the climate panel, to the WCRP, as a more broader experiment that other people do. And my last quick comment is that I think you mentioned that climate change will be one of the issues that will be harder, but it should address at all time scale, intraseasonal, seasonal, monthly, and because see, one thing people have missed about weather predictability, Lorenz wrote a very important paper that 10-day forecasts have improved a lot. But the reason they have improved a lot is because 1-day forecast has improved, okay? This is something that is not recognized because after 1 day, the instabilities take over. So all the errors in initial conditions in model, And I have a feeling, and nobody has shown that, this can apply on a longer time scale. So we have to do 3-week, 4-week forecast. And by the way, the reason we worked on seasonal forecasting because there we found a source of predictability. That doesn't mean that's the most important problem. For India, most important problem is week by week prediction, at least for 3 weeks, 4 weeks. And there's a lot of work going on that week by week forecast, which I know work is going on here also. So include all the time scales. One thing that was not in the list, I think you should include aerosols, because the role of aerosols in both intra-seasonal variability, and I think it's getting more and more established, but it's a great proposal. I wish you good luck. Thank you.
Thank you so much, sir, for your insight.